Good afternoon, warriors. Today we're going to be learning how to find the area of parallelograms and rhombuses. So start your 2-column notes with me. And I'm going to use what I started yesterday's with, so you still see my squiggly line. I couldn't draw straight. But we are working on the exact same standard, but this time it is area of parallelograms and rhombuses instead of area of triangles. So let's get that out of here. Oh, that didn't work. Alright, so we have area of parallelograms and rhombuses. Your standard is still 6.ee.a.2.c. We are still focusing on evaluating expressions at specific values for their variables, including expressions that arise from formulas used in real-world problems. So we're giving you some formulas as we discuss finding the area of rectangles and triangles and now parallelograms and rhombuses. You have to have these formulas memorized. So write them down on flashcards if you need to, practice them daily, have a partner quiz you, quiz someone at home. If you don't have them memorized, you're not going to be able to master this standard. And just so you are aware, these also cover a geometry standard that we're going to be working toward mastery of later. But right now we're focusing on our equations and expressions. 2 words that you need to add to your notes today. First of all, rhombus to the left-hand side. And then let's discuss what a rhombus is. A rhombus is simply a parallelogram that has 4 equal sides. So a rhombus would be a parallelogram equivalent to a square. All 4 sides are equal, but when you'll notice, when you look at a parallelogram, it's slanted as opposed to a square that might look straight up and down. So a rhombus would look more like this, pretending all 4 sides are equal. And these 2 sides are parallel, and these 2 sides are parallel. A parallelogram is a quadrilateral. That's a 4-sided figure. It has the root quad with both pairs of opposite sides. So this side and this side, and this side and this side. Both pairs of opposite sides are parallel, hence the word parallelogram. And it says equal in length, but all that simply means is, yeah, we have that slant. Pretend my lines are straight. That side is equal in length and parallel to this side. And then this side would, of course, be straight and equal in length to this side. In a perfect world where I wasn't trying to draw with my finger. So if you need more time to copy these down in your notes, go ahead and pause the video and continue. Otherwise, I'm going to move on. And today I'm taking the lesson out of 12-3. Oh, I signed out of my e-text. Let me get back in. I'm taking a lesson out of 12-3, or I'm sorry, 12-2, which is area of parallelograms and rhombuses. And let me open up my text here. If you run into problems today, it's up to you to make sure you stop and ask the substitute your questions. And the substitute can go through with you on what you're working on and where you're stuck and hopefully unstick you. You can also email me at any time with any questions that you have. You also have this e-text available for you. on your computer. And we're going back a lesson today to 12-2. Alright, the question is, how can you use the formula for area of a rectangle, which we learned back on Tuesday, to find the area of a parallelogram? And they want you to see here in the visual that a rectangle, which is what we ended up with here at the end, is actually closely related to the parallelogram. If I took a parallelogram, and if I was there with you, we would do this actual activity in person, and I cut off the little triangle at the end in a straight line that makes a 90-degree angle with the base, I could take that triangle, swoop it over here to the other slanted side, fit it in perfectly to form a rectangle. That should give me some information here about finding the area of a parallelogram. Think about it for a second. If I can cut this triangle off, flip it over here, I haven't changed the area at all. I'm still talking about the exact same area, which is everything here that's blue inside the parallelogram. I'm just moving it to the other side, but I haven't changed the area at all. I should see that the area of the rectangle here would be exactly the same as the parallelogram here. So, would my formulas be the same? You should come up with yes. The formula is essentially going to be the same, but when we talk about parallelograms, instead of calling this the length, we're actually going to call the bottom here the base. Okay, and we're going to talk about base and height because we need a height that is straight up and down. So, when we take a look at the examples they give us on your visual learning bridge, if I push the right button, we can see that the base of the parallelogram is equivalent to the length of the rectangle. These two figures here have exactly the same area because all they did was chop off this triangle and move it to the end. When we chop off the triangle, we've created a straight line that was the width in a rectangle, and now because we're mathematicians, we're going to call it the height in the parallelogram. I know I can use this as the height because I can draw a box down here on the corner between the height and the base, and if the box is truly a 90-degree angle, I have a height that I can use. So the formula to find the area of a parallelogram is going to be much like finding the area of a rectangle. We're just going to change the length to a B for base and the width to a H for height. But the area of a parallelogram is area equals base times height. The B times the H. We cannot use a slanted sides measurement. And they're going to try and trick you on that. Don't let them trick you. Also, think back to yesterday's lesson on area of a triangle, where we simply cut this parallelogram this way or that way into two equivalent triangles, and suddenly we understand that the area of a triangle is going to be half of this, half of base times height, because we have two triangles here and we would want the area of one. So it's all related. And again, the only way that you're going to master this standard is have these formulas memorized. So you should have the area of a parallelogram written down in your notes and practice it, practice it, practice it. Another way to write this formula is simply to write, and you'll see it right here, area of the base times the height. Remember, if there's no sign here, we're multiplying. So we have two factors, the base and the height, and we're multiplying them together. The product will be our area. If we move on to guided practice and get a little feel for how these problems go, much like Tuesday and Wednesday's lessons, you're simply going to be doing some multiplication to find the area. We do not add when we're finding the area. We multiply because we're trying to find all the square units inside of a figure. We're not trying to find the perimeter, which goes around the outside, like when we run laps. We're trying to find all the square footage inside. The directions say, use a formula to find the area of each parallelogram or rhombus. It doesn't matter if it's a rhombus or a parallelogram, we're going to find the area the same way. So again, just like yesterday in 3-column notes, you're going to set them up for number 1. In the first column, you're going to write your formula so you can practice memorizing it. The more you write something down, the easier it is to remember. So for this, we're going to write area equals base times height, or A equals B times H. And then we're going to substitute in the middle column. So your area is still going to equal your base, which is 20 inches, times your height, which is 21.5 inches. Remember your commutative property of multiplication. You can put those in any order. So what I'm going to do here is I'm going to start on a new board, just so those of you that are visual learners can have that visual that what I'm doing for number 1, I've started my 3-column notes. Okay. In the first column, I am writing the formula. So area equals, for parallelogram, it's base times height. I like to write it this way, so I sound like I'm very smart and I'm a mathematician. Now I substitute what I know. So I know that the area equals, I go back to my problem over here, the base, which is 20 inches. So for the B, I'm going to put in a 20. Okay, and then it's base times height. So for the height, it tells me it's 21.5 inches. I'm going to use parentheses to separate my numbers, because I know that that still means multiplication. And I'm going to multiply 20 by 21.5. Now I know that when I multiply decimals, it doesn't matter. I can put them in any order because of the commutative property of multiplication. They could communicate in any order. So I'm going to put the longer number on top just to help me out. And I don't line up decimals when I multiply. I wait till the end, and then I magically change my whole number back into a decimal. So I have 21 point. Make sure your point looks like a point and not a number 1, Miguel. 21.5 times 20. And I'm going to do the multiplication down here, because I can't do that in my head. I can estimate, and I can say, okay, well, 20 times 20 should be about 400. My answer should be about 400. So let's see if I'm right, if I'm anywhere near that. So first of all, I got the 0 times everything, and I've seen some people do this, and this helps keep me straight. So I'm actually going to put 0 times 5, 0. 0 times 1, 0. Because remember, I've changed all these into whole numbers. So I'm not using the decimal till the end. 0 times 2, 0. And I've changed them all into whole numbers by multiplying. Okay. So the 0 is done. He's going to take the 1 spot down below and hold his place. Now I have 2 times 5, which is 10. 2 times 1 is 2, plus 1 is 3. Make sure I line up these places here. And then 2 times 2 is 4. Now I should be ready to add. And hopefully I'm doing all this math right. It is very late at night, so you guys could be checking me. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 3 is 3. 4 plus 0 is 4. Now, I have to take into consideration that I have to turn this whole number back into a decimal by dividing. And I have 1 decimal place over here, so I'm going to use my shortcut. I'm going to start at the end of my whole number. I'm going to swoop in that 1 decimal place. And I've changed 4,300 into 430, which is very close to my estimate. So my answer over here for the area of this parallelogram is 430 30. I can leave the decimal, or I don't have to write it now. And I go back to see my units, and now I'm talking about inches. Since I'm finding area, it's inches squared, that little exponent. And that's what it should look like for number 1 on your 3-column notes. You're going to try 2 and 3. Show 2 and 3 to the substitute and have him check and see if you are correct. If you're correct, you can move on. If you're not correct, you need to find out what you did wrong. If you're moving on, you're going to do the independent practice on page 321. You're going to do 6 through 14 even, and then get the math homework for tonight on area of parallelograms and rhombuses and start that if you finish early. Don't forget to also finish the guru, because there'll be another question after this. So you're doing 6 through 14 even on lesson 12-2. And then when you're getting stuck, if you have questions, ask the substitute. Remember that you are in charge of your learning and you need to take control of that learning, especially when I'm not there to help. Email me with any questions or any problems, and make sure that when I could return on Monday, you have a really good grasp of these formulas and you have them memorized. That's the most important part of the lesson today.